Hi folks, welcome back to Everything is Swift. Today let's solve the minimum domino relation for the equal row Leetcode problem. So to understand a little bit more about the problem, let's dive into it. So the question means in the row of a domino's tops and bottom represent the top and bottom half of the I domino. A domino is a tile with the two numbers from 1 to 6 on each half of the tile. I think this week is everything question is related to domino during this day. That we may route the I of dominoes so that tops and bottoms I swap the values. Return the minimum number of rotations so that all the values in tops are the same or all the values in bottom are the same. If there's no same domino values, we just need to return the -1. So let's more deep dive into the example 1. So in here, it's mentioned that the dominoes arrays given in the two arrays, one for tops, one for bottoms. So we need to check how many swap we need to do to match all the tops or bottom in the same numbers of the domino values. In here, it's mentioned that we just swap the top of the index 1 and then top of the index 3. So we got the all 2's above the top of the dominoes and we just return above the 2's. But there's other ways around. How about we put all the 2's in the below? The situation is like this. Move this 2 to here, this 2 to here, and then this 2 to here. So that will be 3. So what we need to return is the minimum numbers of the swap that we need to make the top rows equal to the 2's. So that is XML case. How about the XML 2 that they provided? Let's check the XML 2 together. In XML 2, there's given like two arrays like for tops and bottom as usual at the first XML. But the thing is, even though we trying to swap all these number, you see like 3 in here, 3's in here, 3's in here, 3's in here, 3's in here. But here, there's no 3 at all. Even though how many times we swap a flag like top and bottom, there could be the no ways to receive the values of their final result. So we just return the above the -1. Alright, let's deep dive into the code and let's solve in Swift as usual. So in that case, what we should do first is, instead of iterating through all the number from 1 to 6, we could save the number by just indexing the index 0 of top and index 0 of the bottom, and we compare with all through all the domino. So we could save a lot of time. Let's say if we trying to iterate through like 1 to 6, that will be the 6th time into 2, because the domino include the 2 parts, top and bottom. But if we decide that to use only 1 and 2 number, so they will do the 2 into the 2, which could save a lot of computation power for us. So to iterate through, let's call it like doing the target in top of index 0. So we need to check the constraint before we go through it. So I'm pretty sure the constraint is top is always more than 2, so we can use a index 0 instead of like checking any other condition. And then whatnot. So we also need to check like how many swap we done in here. Let's call it top swap will be 0, and then bottom swap will be 0. That's our case. After that, what we need to do is, let's call it since we are receiving the two arrays with the same size, we can zip it in the Swift to achieve the result instead of like going through one by one from like top iterative one approach, bottom iterative one approach, which is a lot of wasting the computation power for our program. Let's do a zip for top and bottom. After that, we need to decouple back the pair. Let's go top helm. Oh wait, we also can do, okay, never mind. So we also need to check the case for the Ethernet too. If the number is not same with any other numbers in the first array or second array, we just need to break it. If top target or should be the not, just break it. If top not equal to target, what we can do, we just +1 to the top swap. The same for the bottom. Should be the bottom swap. Another thing we need to do is like we have to check we have reached the last part of the array by checking like index +1, tops.count. We can just return like minimum of the top swap and bottom swap. We also need to return the -1 here. Let's try the run. Oops, there's some typos. Oh yeah, to check the index we have to change it into the enumeration. Let me check what is the issue happening. Let's returning the 0. Top swap, bottom swap. Maybe the loop is not going out. Tops, bottoms. We decipher in here as a pair. And then, oh, that should be the bottom swap. What a minor faults. My bad. Alright. Let's check the speed complexity and time complexity. I think for the time complexity will be the O of n, since we don't have a nested or anything. For the space complexity, it is O of 1, since we don't take any extra memory. But if we want to increase the runtime in here, we could save the performance by instead of counting the index every time. Let's call it like let domino count. Get update in here. Should be error. Let's try it again. So it's a 3 millisecond. Oh, what was the issue? Okay, not sure why I'm doing a lot of clumsy typos throughout the recording. Okay, I think this is a cache or something, but at least the runtime is slightly dropped. Okay, that's all for today. Thank you so much. See you next day. Bye.